Lesson 7-2, Coulomb's Law. Point charges exert forces on each other, or a force on each other. They're related to the size of the charges and the distance between them. If the signs are the same, so they're both positive or they're both negative, the force repels. If the signs are opposite, then they attract. Positive and a negative would attract. The force from the first charge into the second charge is equal to the and opposite to the force of the second charge to the first charge, because that is Newton's third law. So Coulomb's law says that the force between 2 point charges is kQq over r squared. And that's absolute value of the charges, where F is the electrostatic force, K is Coulomb's constant, 8.99 times 10 to the 9 Newton meters squared per Coulomb squared. The Q's are the charges, and R is the distance between the charges. This is a force. To get the direction of the force, you'll have to look at where the two charges are and whether they attract or repel. In a hydrogen atom, the electron, whose charge is negative 1.6 times 10 to the negative 19 coulombs, is that distance away from the proton of equal charge magnitude. Find the electrical force of attraction. So our force is kQq over r squared. K is 8.99 times 10 to the 9 Newton meter squared per Coulomb squared. Then there's the absolute value of the charges. So we have the electron, and the proton is the same charge but positive. Doesn't really matter in this though, because it's absolute value. And then it's the distance between them squared. Put all that in the calculator, and I get 8.22 times 10 to the negative 8 newtons. A few other notes about Coulomb's law. Notice the similarity to Newton's law of universal gravitation, which was the gravitational force is G m over r squared. So the constant, there's a constant. For electrical, there's a K. For gravitational, it's G. And then there's the size of the thing. So we have the masses, or in Coulomb's law, the sizes of the charges, and they're both over r squared. So the force is proportional to 1 over r squared, which means that if the distance increases by 4, the force decreases by 4 squared, or 16. If there's more than one charge, if we're looking at the force on one charge given by two others or more, you work in parts. Because we do the force of attraction by one of the points, and then the force of attraction by the other point, and then add the vectors. But remember, they're vectors. You'll have to add the x components and the y components, and do Pythagorean theorem and inverse tangent and all that fun stuff. So let's say there's 3 charges in a straight line. Q1 at negative 0.1 meters. And it is 2 microcoulombs. And then we have Q2 at 0 meters, which is negative 3 microcoulombs. Then out here at 0.3 meters, we have Q3, which is positive 5 microcoulombs. What is the force on charge 2? So let's look at just force on 1 and 2. So if I go the force of 1 on 2, of course that's K, Q, Q, over R squared. K is 8.99 times 10 to the 9. Q1 is 2 micro, so that's times 10 to the negative 6 coulombs. Q2 is the negative 3 times 10 to the negative 6 coulombs. And the distance between them is 0.1 meters. Run that through the calculator and we get 5.39 newtons. But which way is it going? Well, Q1 is positive, Q2 is negative, so they're going to attract. So that would pull Q2 to the left, which I'll call negative, because it's attracted to the positive Q2. So the Q1 is attracting Q2 towards the left. That is why I made it negative. All right, let's do the forces between 2 and 3. So it'd be Q2 and Q3 this time. K is still 8.99 times 10 to the 9. Q2 is negative 3 times 10 to the negative 6. Remember, micro is times 10 to the negative 6. Q3 is 5 microcoulombs. And our distance is 0.3 meters. Don't forget to square it. Run that through the calculator and we get 1.50 newtons. But which direction? Well, remember we want the force on Q2. Q3 is positive, Q2 is negative, so it's attracting. So Q3 is attracting Q2 to the right. So it'll be positive. I'll call it positive. And then we'll find our total. Negative 5.39 because Q1 pulls it to the left. Plus 1.50 because Q3 pulls it to the right. Gives us negative 3.89 newtons. What's that mean? That means our force is 3.89 newtons towards the left or towards Q1.